Hello learners, welcome to this course on practical machine learning using Google Colab. So in this tutorial, let us continue with our discussion on the fundamentals of computer vision part 6. So here I am going to discuss about an important operation in an image processing task, which is smoothing and blurring an image. So in this tutorial, I will show you what are all the different types of blurring methods like average filtering, Gaussian blurring, median filtering and bilateral filtering. How to perform this using your Google Colab environment. Okay. So let us open the program file in Google Colab environment. So in order for my notebook to get connected with the cloud-based environment, you can go and select your hardware. So you can go to edit, go to notebook settings, and here you can select the type of hardware accelerator you require for your application. Either you can select a GPU, TPU, or you can select none, which is nothing but we will be trying to use a CPU. So what type of environment or hardware accelerator you require for your program. So for this I am going to use a GPU. Save. First let us discuss about what is smoothing and blurring. So blurring happens when a camera takes a picture out of focus. So if the camera is moving when it is capturing an image or when the object is trying to move, then there is a chance that the focal length might not be a fixed one. Focal length of your lens in the camera might not be a fixed one. Thereby the image looks out of focus. So when this happens, what happens? The sharper regions in the image lose their details. So the sharper regions gets merged with the background information. So how to reduce this or how to do this is typically using a low pass filter. Usually the noise is a high frequency signal. So by using a low pass filter, we are getting only the low frequency information. All the high frequency information like details, high details and noises can be removed. So it reduces the amount of noise and also the details in an image. So once I reduce the noise and the details, we can easily find the objects in the image. So thereby I can easily focus on larger structural objects for feature extraction or for some other image processing tasks. So there are four major types of blurring techniques. One is averaging, Gaussian blurring, median filtering and bilateral filtering. Let us discuss one by one in detail. First let us start with averaging. So average filter or box filter or mean filter. It considers an area of pixels surrounding a central pixel, averages all these pixels together and replace the center pixel with the average. So we take a neighborhood. In that neighborhood, we consider all the neighborhood are going to equally contribute to the center pixel value. Then we call it as a average filter or box filter or mean filter. So here I have shown two types of kernels. Here I take a 3 by 3 neighborhood. Here I have shown a 5 by 5 neighborhood. Here you have seen that all the neighborhoods are being assigned with the same weightage 1, which means for the central pixel computation, all the neighborhood pixels are going to equally contribute for the computation of the central pixel value. So same way for a 5 by 5 also you can see the complete neighborhood 25 pixel neighborhood is going to equally contribute for the computation of a center pixel value. So this filter, averaging filter, can be applied on top of your image and we can perform the convolution operation. So I strongly recommend to look at my earlier video on what is a kernel and how to do the convolution operation. So that will give a better idea on how this blurring operation takes place. So we take this kernel and put it on top of your image and try to do a dot product or a convolution operation. So by doing so, we will get the blurring effect. So we have certain properties for the averaging filters. So this averaging filter should be odd ordered, like 3 by 3, 5 by 5, 7 by 7, 9 by 9, because it should have a center pixel value. And the sum of all the elements should be 1. And all the elements should be same in the kernel matrix. So increasing the size of the filter will result in increasing amount of blurring. So if I want to increase the amount of blur, I can increase the size of the kernel, thereby the amount of blurring will be more. Second type of blurring which we are going to discuss is Gaussian blurring. So it follows a Gaussian distribution. The kernel follows a Gaussian distribution. So Gaussian, you can see it is something similar to that of average blurring, but instead of taking a simple mean, we are going to use a weighted mean. Weighted mean in the sense where the neighborhood pixels that are closer to the center pixel will contribute more to the weighted average of the center pixel. So for example, here I have shown a Gaussian pixel. So here you see at the center point I have a higher weightage. As I go towards the outer side of my kernel, you can see the value gets reduced, which means, as I said, if you see along the left direction or right direction, top, bottom, or along the diagonal, you can see the value gets reduced, which means it follows a Gaussian distribution. So Gaussian distribution, at the center point you will have a maximum value, on the left side it gets decreased, same way on the right side it gets decreased. So which means the pixels which are closer to the center pixel value is going to have a higher weightage in contribution when compared to the far away pixels. You can see the far away pixels are going to contribute very less to the computation of your center pixel value. As the name suggests, the Gaussian smoothing is used to remove noise that are approximately following the Gaussian distribution. So, and this Gaussian filtering will be more naturally blurred and it preserves more edges in our image when compared to your average filtering. The third type of filtering which we are going to discuss is median filtering. So here in median, what we do is we try to find the median of the values in the neighborhood, and that median value will be used for replacing your center pixel value. For example, here I have shown a 3 by 3 neighborhood. So I try to arrange all these values in an ascending order, then try to find the median value. So here I have 9 values. So in this 9th value, the 5th value is the median, center point. So this center point value 124 will be used for replacing the 150. And then move this median filter towards right by 1 position. Again do the same computation. So we run this matrix from top left to right, and then from top to bottom we try to compute. So thereby we get the median filtered output. So it is most effective when I have something like a salt and pepper noise. Salt and pepper noise is something like small white patches on an image. Here and there in a random fashion, if I have some small white patches, so those type of noises can be easily removed by the median filtering. And one more important thing to consider here in median filtering is the kernel size should be a square. We can't have a rectangular type of kernel size. So it should always be a square, a 3 by 3, 5 by 5 or 7 by 7, we can take like that. And this median filtering, it works very well for damaged photos or aged photos, or the photos which captured in the suboptimal condition. If the lighting condition is not proper while capturing the photo, then such photos can be processed using this median filter, and it works really well for those type of images. And the final type of filtering which we are going to discuss is bilateral filtering. So bilateral, from the name itself we understand bi means two. So we are going to apply two filters together to get this operation. So usually in other filtering like averaging, Gaussian, or in median filtering, when we try to do the blurring of an image, what happens? We lose some important details also. We are removing the noise, but also we remove some of the details in the image. If I want to reduce noise and also to preserve the details in the image, it is better to go with bilateral filtering. So here in bilateral filtering, we use two Gaussian distributions. We use two Gaussian distribution. One Gaussian distribution considers the spatial neighbors as we discussed earlier. So the pixels which are closer to the center pixel will contribute more when compared to the far away pixels. So that is one Gaussian distribution. And the second Gaussian distribution, it considers the pixel intensity or color. So the pixel intensity or color which is very closely resembling the center pixel will contribute more when compared to the pixel intensity or color information which is little bit deviant from the center pixel value. So we use two Gaussian functions. One is related to the spatial position and another one is related to the color or intensity of the pixel in the neighborhood. So in the first Gaussian distribution, the nearby pixels contribute more to the center pixel value when compared to far away pixels. In the second Gaussian distribution, the pixel intensity or color of the neighborhood pixels which closely resembles the center pixel will contribute more when compared to the pixel or intensities which are little bit deviant from that of your center pixel. So this type of method will help in preserving the edges in the image, and also we can reduce the noise. The main downside of this bilateral filtering is it is considerably slower because we need to compute two Gaussian computations needs to be carried out. So it will be little bit slower, but the result will be very good because we will not lose any details from the object. Now let us look at the programming part. First, let us get connected to the cloud environment. Press this connect button. It will get connected to the cloud environment. It is getting initialized and then it will get connected to your cloud environment. Okay, now it is connected. Now let us discuss the program on how to do this filtering operation like average filtering, Gaussian filtering, median filtering and bilateral filtering. So first we import the necessary packages. So we use cv2_imshow function which is from Google Colab patches. Try to import it to our code. Then I'm going to use some pyplot. So this and all is a default importing functions which we require for most of the programs. So matplotlib as a pyplot and it can be used for plotting the graphs and all. So then CV2 is a computer vision version 2 package and NumPy is a numerical Python library which is mainly used for your matrix or array computations. In short form, we will be using it as NP. So this type of packages we try to include in most of our programs. So by default, we try to add all these packages. Next, we are going to import an image into our Google Colab environment. So I am going to upload an image. So let me select an image. I am going to select this apj.jpg image. It gets added to your Google Colab environment. Now I am going to read this image using this cv2.imread function. So I read this image and try to plot it and see how it looks like. So when I execute this, you will see the image. This is the image which we are going to do blurring. Next, I am going to define 3 different kernel sizes. 3 by 3 kernel, 5 by 5 kernel and 7 by 7 kernel. So to see the effect on the increase of my kernel matrix, we try to define this 3 different types of kernels. So here I try to plot the image, and first we are going to apply our average filtering. So in average filtering, in this for loop, I am going to take 1 by 1 the kernels. So first 3 by 3 will be obtained in this kx and ky, and in order to do average blurring, we use a function called as cv2.blur. It will perform the average blurring. So I give the image and the kernel size. So after the blurred image, we try to see that blurred image, how the original image looks like and how the blurred image looks like. So let us run this code, and when the for loop runs for the second time, then the kernel size will be 5 by 5, and the for loop runs for the third time, it will be 7 by 7. When I execute this, you can find this is the original image. When I blur it with 3 by 3 kernel, you can see the difference here. So the details are something like this stripes. Wherever there is a changeover of the pixel intensities. So that is nothing but the details. So those details are getting lost when I try to do the blurring. So the details are getting merged in the background. So here you can see it is a more smooth surface. So here you can see some small lines on Dr. APJ Abdul Kalam's forehead. So those things and all, it is getting removed when I try to do the blurring operation. If I increase the size of the kernel, what happens? You can see much more blurring takes place. Further, if I increase the kernel size, you can see we are almost losing the information. Next type of blurring which we are going to discuss is Gaussian blurring. So here again the same operation, I am going to use the 3 different kernel sizes. In order to perform the Gaussian distribution, we use the function cv2.Gaussian blur. So I give the image and the kernel size, and here I specify 0. In the Gaussian distribution, I have a parameter called as sigma. So this sigma needs to be given by the programmer. So if we don't know what should be the sigma value for a particular image, we can make our software to do the computation for us. So by specifying 0, the sigma value for an image will be automatically computed. Okay, we need not worry about the sigma value in the Gaussian distribution. So it will get automatically computed, then it will be used for your blurring operation. So as usual, we do for 3 kernel sizes, and we will try to look at the output. When I run this code, you will see the original image and Gaussian blurring using 3 by 3, 5 by 5 and 7 by 7. You can see here it is much more natural blurring. It is not that much over blurred. When I compare it with my average blurring, here you can see most of the details have been lost in 7 by 7. Whereas in case of your Gaussian blurring, still it is somewhat better when compared to your average blurring. But still we are losing some details, but it is somewhat better when compared to your average blurring. The third type of blurring which we are going to do is median filtering. So for median filtering, as I said earlier, we should use a square matrix. So here I define the k value as 3, 5, 7, which means I am going to use a 3 by 3 kernel, 5 by 5 kernel and 7 by 7 kernel, which is a square matrix. And using the square kernels, we compute the median filtering. So I give cv2.median blur, image and the kernel size. Then we will try to look at the output. So when I execute this, you can see the original image, and for 3 by 3 how it looks like, 5 by 5 and 7 by 7. And as I said, this median filtering is very popular for removing your salt and pepper noise. Salt and pepper noise is something like a white patches, small white patches on your image. So those noises can be easily removed using this median filtering. And the final filter which we are going to discuss is your bilateral filtering. As I said, in bilateral filtering, we will be using two Gaussian distributions. So one on the spatial position and another on the color intensities. So we need to define certain parameters. So here we try to take a circular kernel instead of having a rectangle or square kernel. Here I am going to consider a circular kernel. So when I take a circular kernel, an important parameter is the diameter of the kernel. So we need to define the diameter, whether I should have a small circle or larger circle, whether I should have a small neighborhood or a larger neighborhood. So that we need to consider. So that is one of the parameter. So here I define three parameters. So the first parameter is the diameter of my kernel. Okay, so I am going to take 11 pixels along the neighborhood as a diameter. And the second value defines the color deviation. Color deviation in a Gaussian distribution. If I put a larger value in the second parameter, so this second parameter is called as color sigma. We have two Gaussian distributions. Since I have two Gaussian distributions, I will have two sigma values. So one sigma value for color and another sigma value for your spatial location. So this second parameter is a color sigma. Third parameter is your spatial sigma. So color sigma, if I take a larger value, which means I am using more color information in the neighborhood for the computation of my center pixel values. So if I add all the color information, then we are essentially losing our bilateral filtering. So it is always better to have a low value so that the very similar color components can contribute more to the computation of your center pixel value. And the third one is your spatial sigma, which gives whether my nearby pixels is going to contribute more when compared to your far away pixels. So we define these three parameters: the diameter of the kernel, colors sigma, and spatial sigma. So we try to vary this to see the effect on our blurring operation. So as usual, in a for loop, we define this parameter, diameter, sigma color, and sigma space. Then in order to perform the bilateral filtering, we have a function cv2.bilateral filter. So here I give the name of the image and the parameters. Thereby the bilateral filtering computation will take place. So when I execute this is the original image, and you can see the bilateral filtering for the diameter of 11, sigma color is 21, sigma space is 7. So here you can see, even though blurring has happened, we are not losing the details. The details remain the same. Even though smoothing has happened, the details remain same. So that is the advantage of having your bilateral filtering. If you don't want to lose the details, it is better to go with bilateral filtering. But the only drawback is it will take more time for your computation to take place, because it needs to execute two Gaussian distributions. So here you can see a much more very good version of your blurring. So here we are not losing any details, but also the wrinkles, everything has been removed. So the noise component is removed from our image. So in this tutorial, I have discussed about blurring and the different types of blurring operation, like average filtering, Gaussian blurring, median filtering, and bilateral filtering. Thanks for watching. Please subscribe for more technical learning. Thank you.